And today I'm going to talk to you about what's new in OpenTelemetry. But before we start, I want to just get to know you. So how many of you have heard of OpenTelemetry with a show of hands? Okay, that's amazing, almost 100%. And how many of you use OpenTelemetry? Okay, interesting. So about 50%, I think, or a bit less. So that's nice, and it shows the growth. I've been giving talks about OpenTelemetry around the world, and it's nice to see how the adoption growth and the familiarity carries on. And one last question. This will be a more complex question than yes, no, but the question is, sorry about that. I thought I'm missing a slide here, but I wanted to ask you one more question about that. Let me see. Just a second. So we'll do that without the slide. I thought I prepared the slide. But how many of you, how many tools do you use for your observability in your companies? And we'll do that according to numbers. How many of you use, and I'm talking about logs, metrics, traces, app, infra, cloud services, everything all together. How many use up to 3 tools, or 3 or more tools, with a show of hands? Okay, how many of you 5 or more? Let's see how many hands stay up. Look around you. And how many of you 10 or more? Okay, okay. I think some of you will discover that there are other tools that they're not even aware of, but we'll discover that later. So this is going to be the topic today, and my name is Dotan Horovits. I'm the principal developer advocate at logs.io. Logs.io provides a cloud-native observability platform that's built on popular open source tools such as Prometheus, OpenTelemetry, Jaeger, OpenSearch, and others. And provides it as a managed platform. I'm also a CNCF ambassador, the Cloud Native Computing Foundation that's behind OpenTelemetry and many of these other projects, and Kubernetes, of course. And I also host a podcast called Open Observability Talks. If you're here, it might be very relevant for you. So if you like podcasts, do check it out on your favorite podcast app. I'm also one of the organizers of the KCD, the fellow KCD in Tel Aviv. So if you're around, do check this one out, and many others. And you can find me everywhere at Horovits, as you can see. So if you're tweeting or tooting or posting anything from this talk, do tag me so I can see that. So the topic today is going to be about OpenTelemetry. Just a second, I want to check because for some reason I'm missing a slide, and I want to check that I'm on the right deck. I suspect that I'm not. So just a second here. Apologies for this. And I want to have, just a second. Okay, let's try this one. See if this is what we're looking for. And let's do this magic, and let's try this. So, I want to talk about the vision for observability. We all know that observability is the way that we understand the state of our system based on the telemetry that it emits. And the vision talks about unified observability across the different signals. So logs, metrics, traces, and as we know, as we'll see, there are even others. And also across different sources. So think about your app, your infrastructure, open source tools that you use, Kubernetes and others, cloud services, whatnot. And essentially fusing all of these together to gain observability into what's going on in our system. That's the vision. But the reality is much more fragmented. And the reason is exactly what we asked before about the increasing number of tools, the different tools that we use for our observability. Different tools, and each vendor in each tool and each open source has its own way to instrument the application, and then its own way to agents, daemons, collectors to then collect the data and to aggregate and to do all sorts of sampling and processing and whatnot, and then its own way to transmit the data and model the data. And all of that, first of all, it's an operational headache, I'm sure that you'll agree. But the main pain, going back to the vision of observability that we talked about, is that it creates silos. It creates silos that makes it very difficult for us to ask questions that are cross-cutting across the different silos, across the different signals, across the different sources. Okay? And it also creates tight coupling between the telemetry collection and the backend storage and analytics. And that prevents the unified observability we talked about before. And this is what OpenTelemetry comes to solve. So OTel, if I call it OTel, that's a short for that, the same thing, is a framework, as you can see, for generating and collecting telemetry data across the different signals, logs, metrics, traces, and across the different sources. So if you will, one framework to rule them all. And it's an incubating project under the CNCF, proud to say as a CNCF ambassador. It started off as a merge, in fact, of two different projects or specifications under the CNCF, Open Tracing and Open Census. Back in 2019, it got accepted into the CNCF sandbox, and then in 2021, into the CNCF incubation. And now to the first big news of what's new with OpenTelemetry. OpenTelemetry, just last week, fresh, hot off the press, has applied for CNCF graduation. So first of all, I want to applaud to the CNCF. Let's show the support in getting this done. And this is, in fact, a major milestone. So just to make sure that you understand what it means, the CNCF defines an open source project maturity model. And it goes from, as you can see here, from sandbox to incubating here at the lower part, and into graduation. And then the TOC, the Technical Oversight Committee, evaluates the project at each milestone to approve its maturation into the next level. So this is the process, and OTel, as I mentioned, has been accepted to the sandbox back in 2019, then into incubation 2021, and 2024 should be the big year where OTel will get into graduation. And very important to say, this maturity model is about the open source maturity, not about the maturity of the software for delivery into production. I'll talk about that in a minute. But this is about the open source maturity. We're here at an open source conference at scale, and open source signals such as how many active maintainers there are, what's the diversity of organizations, how many different organizations are involved, what's the release process, the fact that there are regular releases of the software and so on. So all these signals that indicate the health and maturity as an open source project, this is the model that is modeled here. So this is the first update, but now I want to talk about this activity that merits graduation, and talk about what's new in the project in terms of the adoption and activity. And the first thing that, again, very proud to say, this is OpenTelemetry is today the second most active project in the CNCF, second only to Kubernetes itself. And this is taken from the CNCF DevStats. It's an open source, open Grafana dashboard. You can see that this is in the span of 30 days, but it's been consistent for over a year. So it's pretty consistent, the second project. And let's delve into this activity. Let's break it down. You can see that in the numbers here. 55,000 code commits, 67,000 pull requests, 466K contributions, over 9,100 individuals contributing code, and over 1,100 companies on the contribution side. So this is really active. This is taken from the CNCF report that we published recently, a project journey report for OTel, all the way from its acceptance into the CNCF and until the report, end of 2023. And again, let's break it down. Amazing to see the growth in contributors over the years, which has just actually accelerated, if you can see the slope there, in the past year and a half, leading to, as I said, over 9,100. Probably by now it's closer to 10,000. Even more impressive to see the number of contributing companies that has risen every quarter in an impressive rate, up to today's over 1,100. And also good to see the diversity. We can see here that all the major cloud providers are involved: Amazon, Microsoft, Google. All the major monitoring and observability players are here, which is good to see. We can see the largest tech companies, also on the end user part, Facebook, Shopify, Uber. You can see them here. And obviously also smaller players like MailChimp and Mercari and others. And this diversity of code contribution, as I mentioned before, both the diversity between vendors and end users, large companies and smaller startups, shows a very good health indicator for the open source, and in my belief, is a good signal for graduation. We can also see, maybe last stat about the geographical distribution. We can see contributors from all around the world, leading the pack with here the US. We're based in the US, so a big round of applause for all the maintainers and contributors in the US contributing to OpenTelemetry. That's really amazing to see. And as you can see here also with many from Europe, India, Australia, Russia, and many more. I'm actually personally proud that my local community in Israel is listed here among the top 15. You know, Israel, tiny with 9 million people, being able to squeeze in here with the contribution, that's great to see. And OTel is also on the radar in terms of analysts outside of the open source and cloud native realm. We can see an example here from Gartner that started covering OTel on its hype cycle for emerging technologies back in 2022 already. So it's definitely on the radar for major players, and you see Gartner expected it to reach the plateau of productivity within 2 to 5 years. So even analysts believe that it's really about to mature in the coming years. So that's just a bit to give you a taste of the activity, the level of activity and maturity of the project. And now I want to quickly go over the main components of OpenTelemetry to level set the knowledge. I know that many here already started playing with that, but I want to level set so that we can then talk about the updates to the project with the different components. So OpenTelemetry essentially is a unified set of APIs, SDKs, and tools for generating telemetry data, logs, metrics, traces, and others from our application. That's the bluish part on the left-hand side. And then a standard way for collecting the data and processing it. This is the green part in the middle. And then exporting it to any backend of your choice. OpenTelemetry doesn't have any stake in it, so whichever backend you work with, you have the relevant way to export to it, and we'll see that in a second. So let's go and look into each one of these. And before going on the components, I want to say a word about the OpenTelemetry specification. That is not a component by itself, but it actually governs all the components and all the implementations of the OpenTelemetry across the languages. So the cross-language requirements and expectations, and it includes the API spec, the SDK spec, and the data spec, the semantic conventions, and so on, across logs, metrics, and traces. And that comes to solve, of course, the problem we talked about before, that we have too many specifications and each tool and each vendor has its own. This comes to solve it with a unified set to avoid this fragmentation, and also to create semantic conventions that will enable correlation across the signals, okay? So definitely a win. And then there's the client libraries. The client libraries, essentially, OpenTelemetry provides one API and one SDK per programming language, that, of course, according to the unified specification I talked about before. So you have the Java, the .NET, the Python, and so on and so forth. Then it offers language-specific integration with popular frameworks, so you know, RPC libraries, storage clients, web framework, and so on. And also, for some languages, you can find automatic instrumentation agents that allow to instrument your application code without having to modify the source code itself, okay? And depending on the language, of course, but you can find that. So essentially, the vision for OpenTelemetry is to cover everything from fully manual to fully automatic and anything in between. That's the goal with client libraries. Next up is the OTel collector. And the collector can collect from the OTel SDKs I talked about just now, but also from many other sources. You can think about your Kafka, your Redis, your AWS services, or Azure or whatnot, and essentially process and then export them to your backend of choice. So it's built like a data processing pipeline, as you'd expect. You have receivers in multiple protocols. You have processors that you can connect and create all sorts of aggregation and processing logic, and then exporters in multiple protocols. So if you want to collect telemetry from your app, your front end, your back end, you want to collect it from infrastructure components, you just plug in the right receiver. You have, I know, Kubernetes, you plug in the Kubernetes receiver, Docker receiver, MySQL, Redis, HTTPD, AWS X-Ray, GCP PubSub, whatnot. You just plug in the right receiver. Then you have processes that do all sorts of logic, processing, filtering, batching, sampling, and so on. And you can chain them to create more elaborate logic together. And you build up into pipelines, processing pipelines. And then you have exporters depending on the backend you want to send it to. So you want to send it to AWS, you have an AWS X-Ray exporter. You have Azure Monitor exporter, Google. You have Prometheus remote write exporter if you work with Prometheus. Logs.io, my company, also has an exporter, and many other vendors. So really, and also downstream processing like Kafka, everything available for exporters. It enables edge processing patterns, so you can deploy multiple collectors in different junctions to create, to balance the load and the scalability and to increase the throughput. And you can also, it's very performant. A lot of emphasis has been put by the team on the performance, the high speed, low overhead. So a lot of thought and a lot of work by the maintainers to make it performant. And the last thing that I want to talk about is the OTLP, OpenTelemetry Protocol, which is the telemetry data delivery protocol. It's not specifically for OTel, it's a generic protocol that you can relay telemetry data based on the data specification we talked about before. It can be between the SDK, be used between the SDK and the collector. It can be used between the collector and your backend. It can be between any intermediary nodes. It's really general purpose, client-server protocol, request response. As you can see at the bottom, I don't know if you can see, the transport, it supports, it implemented over gRPC and HTTP 1.1 on the transports, it currently supports binary protobuf encoding as well as JSON protobuf encoding payload. So you have OTLP over JSON, for example. And it's, I don't know if you can see at the bottom. And as I mentioned, it's based on the open specification of the data model. Now, it's very important to emphasize, you can use OpenTelemetry without using OTLP. We've seen, I showed you an example just a second ago, that you can use the collector with many receivers in different protocols. You can export in multiple protocols. So you're not bound to use OTLP in order to migrate and start using OpenTelemetry. And this logic actually applies also in general. So you can use the SDK without the collector. You can use the collector without the SDK. It's really loosely coupled architecture, yet a holistic, unified framework for generating and collecting telemetry data. So the goal is to provide the full set, but you don't have to use, and you can use only parts of that. That's the philosophy. Now that you understand the parts and the different components, I would like to now talk about the big news, about what's new and what are the updates. And the biggest update, I think, in OpenTelemetry, besides applying for graduation, is the following. OpenTelemetry's logging piece has reached GA very recently, actually in the recent KubeCon back in Chicago. Whoever was there heard that news. Really exciting news. That was the last signal among the 3 pillars that to graduate, which is great news. But what does it mean when I say logging is GA? Shouldn't I be saying OpenTelemetry is GA? Or is OpenTelemetry GA? Is it ready for production? Can I use it in production now? What do you think? Who says yes with a show of hands? Okay, not many optimistics. Who says no? Okay, who says it depends? Okay, so the answer is it depends. All the rest, I guess, could not decide, but it depends. And the reason it depends is that OpenTelemetry is actually an aggregate of multiple groups, multiple working groups, each one having in charge of a different component from what I described here. And each one has its own maturity life cycle for that specific component. So, and the maturity life cycle in the CNCF goes from draft to experimental to stable and then deprecated. So as you can see, this is a different scale than what I talked about before. Before that was the scale for open source maturity. This scale is the scale of the software maturity, just like you'd have with any software, whether open source or not. With experimental, you could say this is sort of the beta, something that you will start a POC or something with, and stable being the GA, something that is generally available and you can is mature enough to put it in production. Okay? So each component has its own maturity life cycle, and that's what makes it a bit challenging to understand, and hopefully for me to help you navigate through that. So let's start with the maturity of the different signals, the main signals, logs, metrics, and traces, and I will go through that according to the order of maturity. And the first to have matured was distributed traces, that is already stable for quite a few years, meaning that the API, the SDK, the protocol are stable, the collector is stable for tracing pipelines, and there are many client libraries that are already version 1.0 or above. 1.0 is when it's become stable, when the tracing implementation is complete. And you can see here lots of programming languages. I don't know if you can see at the bottom, the largest suite. Also stable, and that's very important, as I mentioned. Stable means guarantees for long-term support, for backward compatibility, for dependency isolations. These are the sorts of things that you would be looking for to run it in production. So that's about traces. Next to have matured was metrics. Metrics, again, the APIs, SDK, protocol are all stable. The API and SDK specifications are already implemented, as you can see here, in quite a few languages. Java, Go, .NET, C++, JavaScript, Python, PHP are already stable. The collector already supports metric pipelines. And very importantly, Prometheus is supported. That's something that has been a great focus for both communities, collaboration between the Prometheus community and the OTel community, meaning that you have the SDK can export, the OTel SDK can export in Prometheus format, and the collector has both receivers and exporters in Prometheus format, in OpenMetrics format. And also, I know it's outside the scope of OTel, but also on the Prometheus side, a lot of work has been done on OpenTelemetry compatibility. There's compatibility also, by the way, between the OTLP specification and the Prometheus specification. It's going to be a big theme, by the way, for Prometheus, the next major release of Prometheus that is planned for this year, the OTel compatibility. So a lot of work there. And the last is logging. Logging has reached general availability, as I mentioned, just less than half a year ago. Last year. You have client libraries already stable in Java, .NET, C++, and PHP. And in general, in logging, there are two paths. The path of supporting existing legacy logging that you already have, the unstructured flat file type of logs. And there's the longer-term path for new specification for strongly typed structured logging. So the first part, that was the introductory part, was to support existing logging. A lot of work has been done to provide an SDK that can fetch the logs and transmit them over OTLP alongside logs and traces. There are log appenders that have been developed in many languages that take the logs and append the trace data, the trace ID, the span ID, to enrich the logs with trace-related data. Lots of work has been done on logging framework. So if you work with, I don't know, in Java, in Log4j or Logback, or in other languages, .NET and others, you may find that you have a built-in way to append just with configuration only using these frameworks. And also lots of, in the collector, lots of log processing has been added in many data formats thanks to the Stanza project. For those who know, this open source project has been donated to OpenTelemetry. So that was the legacy logs, okay? Alongside that, the project has done work to create strongly typed machine-readable specification for logging, something that we've been longing for many years in this industry. And there's been a lot of work around that, and with the stability means that of logging means that we already have a stable data model and reference implementations for to show these things. The data model, the OTLP log protocol, they're all stable. And the big news in this front are that Elastic Common Schema, ECS, has merged into OpenTelemetry log specification. So that means that we take the whole aggregated knowledge of a well-established open source community, the Elasticsearch community, and now this is an organic part of the logging specification in OpenTelemetry. A great win for both communities. And let's talk about some more updates around OpenTelemetry. Going beyond the 3 pillars, which is why I hate this term, 3 pillars make people think that this is the total sum of observability. So no, it's not the total sum of observability. And in OpenTelemetry, after reaching stability with these 3, the next signal to have been adopted, to adopt is continuous profiling. How many are familiar with continuous profiling, with a show of hands? Okay, not many. So a word about continuous profiling. It's very similar to the classic profilers that you would attach to your application, but it's done in an ongoing manner to be able to monitor where your application spends its time, CPU-wise, memory-wise, sometimes also disk-wise, be able to map down functions or specific lines of code into performance. Performance and cost, obviously, are the main drivers for this deep dive. So this is definitely something that is on the OTel focus, and a special SIG, a special interest group, has been formed to drive this. It's called the SIG profiles, and a lot has been done. You can see here on the right-hand side from August 2022 when the profiling vision has been shared, and since then a lot has been done on the open specification, the data model, and so on. And the big news, hot off the press, is that, and this is just from as you can see here, from last month, the data model for profiling has been merged. It's an OTEP, an OpenTelemetry extension proposal that has been merged, which means that it's now an organic part of OpenTelemetry. A great win for this. Means that now it's in a, it's advancing into becoming a mature part of the OpenTelemetry. It's a remarkable journey by the SIG profiles. Actually, last week I had a live stream with members of the SIG talking about this important milestone and talking about where we stand now and what's the roadmap. So again, if you're interested, check out the, it's going to come out after the live stream. I'm going to release that as part of the podcast. So check out Open Observability Talks on your favorite app, and lots of updates that they shared from the activity in the SIG. In general, in a nutshell, there's a data model for profiling, along with prototype implementation of the client libraries and the collector. It's strongly influenced by pprof, for those who know this specification, for existing specification by Google for profiling. So it's an extension, so pprof extended, and really a big theme for OpenTelemetry in 2024. Next up is adding real user monitoring support. So let's be honest, the first focus of OTel was the backend side, Java, .NET, and all the backend logic. You could do some client-side instrumentation with the JavaScript SDKs and so on, but really the native entities for representing session IDs and other elements, and being able to ask questions along the lines of counting the number of users versus the number of new users versus returning users, or visualizing how users navigate through the application UI, or identifying pages that generate high number of errors, and pages with high load latency. All of these sorts of questions that you usually use real user monitoring for, these were not baked into the specification. You didn't have the representation in the data model. So this is part of what we want to achieve with OpenTelemetry. And as you can see, OpenTelemetry started a new SIG, a special interest group specifically for that, client-side telemetry, a couple of years ago, and since then a lot have been done. I gave a few examples here, as you can see, with browser elements and mobile and others. Check it out. You have the QR code here to read more about the real user monitoring SIG, and also check it out on the CNCF Slack at OTel client-side telemetry. Really interesting stuff. Next up, a lot of focus has been done on the operability of OpenTelemetry. So as it matures, people start putting it in production, such as some of you folks, and then we started putting more thought into how to operate it in day 2 scenarios. And day 2 scenarios mean we started with the Kubernetes operator last year, which is, and there are advancements there as well, support for feature gates and so on, but also, very importantly, focus on OPAMP, the Open Agent Management protocol, that supports remote configuration of the agent, status reporting, telemetry of the actual agents themselves back to the backend, and all of that. So a lot of work has been done on that. This is sort of the architecture for OPAMP, as you can see. And it's not really, by the way, just for OTel. It's a general purpose protocol, so it can also, you can see here, I think in the example, you can see, for example, for fluent bit agents and others. So really should be able to support mixed agents, even combination of OTel collector with alongside the fluent bit and things like that. And as you can see, some of the implementations already available in Java and in Go, and might be other languages that I missed, so it's really moving fast. Very interesting advancements there. Another aspect is eBPF for auto instrumentation. How many have heard of eBPF here? Okay, so I don't need to explain, that's good. Essentially, it's a way to instrument without changing the code and without, not a language-specific way of instrumenting, so doing it in the kernel level underneath. And a lot of work has been done on using eBPF to auto-instrument and get telemetry. Actually, I had an episode with Eden Federman, the creator of the eBPF Go auto-instrumentation agent for OTel, who leads the Go auto-instrumentation SIG. And does work on many more other languages, not just Go. And in general, auto-instrumentation, on whether eBPF or not, is a major focus for OTel. So removing the need for you to modify your source code to just get started. You probably will have to modify the code for custom telemetry, but at least for doing the table stake type of telemetry, hopefully to do that without changing the code. OTel demo reached GA, so you have a canonical demo app. It's the astronomy shop that you can see here on the right-hand side. That is, as you can see on the architecture diagram, it's a bit small, but lots of programming languages that are implemented here, .NET, C++, Erlang, Go, and others. Lots of components that you can see here, like Redis cache and the SQL database and Postgres and so on, to really simulate a real-life application to get you up and going hands-on with OpenTelemetry. Another update, sunsetting OpenCensus. For those of you who've still used OpenCensus, or by the way also OpenTracing, it's been deprecated officially. OpenTelemetry has reached feature parity, so it's no longer needed, and time to move on. The repo, the GitHub repos for OpenCensus have been archived since July last year, if I'm not mistaken, so time to move on. And very hot update as well. OTel Day is coming back this year, 2024, this year in Seattle, in June 25th. So you're based here in North America. It's easier for you to get there than me. Check it out and join. It's a great opportunity to meet maintainers, contributors, end users of OpenTelemetry. Check it out. And the early bird tickets are already available, as well as OpenCFP. So if you have experience that you want to share, also a great stage to share about OpenTelemetry. And for the last few minutes, I just want to say a quick word about how to get started with OpenTelemetry, because as you saw, it could be quite confusing, right? Lots of components, each one with its own life cycle stage and so on. So how can you do that? And I want to provide my 2 cents on that. And I start by knowing your stack, your own system and application stack. And ask yourself these 4 questions. First, which programming languages do you use? Okay? And this will help you determine the client libraries that you will need to use, and perhaps also which frameworks that you use. So Java with Spring, Node.js with Happy or Express, and this will help you check the maturity in these regards. Then ask yourselves which signals you want to collect, logs, metrics, traces, profiles, to help determine the receivers that you will need to use, and also the protocols, especially if it's a legacy, brownfield, like, I don't know, if you want to collect from Kafka, you want a Kafka receiver. If you want to collect from Zipkin, you need a Zipkin compatible receiver. So this will help you determine the receivers. And then lastly, which backend analytics tool you want to use, because this will help determine the exporters that you're going to use, okay? And once you've mapped out your stack and mapped it to the relevant components, then go ahead and check the relevant status. There's a status page, opentelemetry.io/status. That's a good place to start. Lots of other resources, like you see the docs, the registry, that essentially helps navigating through the massive GitHub repo of OpenTelemetry. And I'd like to invite you all, of course, to also check the guide to OpenTelemetry that I wrote. That is sort of a beginner's guide to give you in-depth on all the components that I mentioned, and also the status of these, and then a link to the downstream to the specific repos for the components that are of interest to you. So it's a good way to fan out to the official docs. And you have sub-guides, by the way, for the different programming languages. So a sub-guide for Java, .NET, and so on. So you can also have a sort of a hello world for your specific application. So that's about the guide. And with that, I'd like to thank you, and maybe take some questions if we have the time.
Thank you, Dotan, for such a great presentation.
Sure.
You have, of course, time for questions. So if you have one, please raise your hand. I will bring them back to you so it can be recorded for the replay.
Hey, thank you for your presentation. In the slide of the demo app that you showed, you mentioned Postgres as one of the databases there.
Yeah.
So is it possible to instrument Postgres to send OpenTelemetry data without changing Postgres, or?
There's I don't remember what they used, what is used, but there's work. You don't need to change Postgres, obviously.
There's an extension.
So it's an adapter, essentially. It's a receiver that is able to take, and I don't remember exactly what Postgres exposes. Usually what happens with frameworks is it takes what it exposes naturally, and then as an agent, it then transforms it and sends it to the relevant collector. So I don't remember the mechanism specifically because I'm not a Postgres guy. I know there are lots of experts here in Postgres, but usually what it takes the native metrics, converts them, and then sends them off to usually using OTLP.
Thank you so much for this great presentation, as always. How is continuous profiling enabled, though? Is he done through, just a little details on that? Is it going to be automatically enabled during the instrumentation for the application?
Can you say a bit slower? So continuous profiling, what did you want to
continuous
know about?
profiling, yeah. How is he enabled with OpenTelemetry, since it's a new feature that has been added, but how is he?
So it's not a new feature, it's really a signal from the ground up. It means that the SDKs will natively support the ability to fetch, to generate the profiling data from the source code, from the application. Then on the collector side, there will be pipelines that ingest the profiling data. So it's really from the ground up. It's not just like you do with logs. So you'll have SDKs, preferably also auto-instrumentation agents there. I haven't shared that because it's not final yet, but for Elastic suggested, proposed donating an eBPF-based profiler, so that will enable instrumenting without code changes. So we'll have a sort of auto-instrumentation agent for collectors if this goes through, the contribution. So whether auto-instrumented or manually instrumented, this is how it will work. And it's based on pprof extended, as I mentioned, in terms of the protocol itself. Check out my episode, by the way. I think it will answer many more of these questions. So open observability talks. I know that you follow, but yeah. Who else wants to ask questions? Come on. Anyone who will ask questions, including the ones we already have, we have a gentleman here. We'll get a sticker, may the open source be with you, like the shirt. So another incentive to ask some interesting questions.
So what would you say to somebody who has maybe already adopted OTel for metrics and tracing, but maybe looked at FluentBit or FluentD for logging and now has to kind of make a choice? I'm not trying to make it a cage death match, only one can come out alive, but just trying to understand where the pieces fit together and if they're going to cooperate at some point in the future.
So you have already instrumented with FluentD or FluentBit, you said? FluentBit. And you're wondering whether you should converge to OpenTelemetry. It's a very good question, and obviously it's very young in OpenTelemetry, I should say that, and FluentBit has been around for longer, so I would say maturity-wise, FluentBit is in a stable place. So I wouldn't be in a hurry to move. On the other hand, you should understand the advantages of having all the signals run through OpenTelemetry in terms of the correlation. So think about that for example, the data specification, the naming and the labeling of the, I don't know, the pod ID, the node ID, whatnot, will be consistently across all the signals. And then when you want to ask a cross-cutting question, it lends itself. And also in the processing, you run it through the same processing pipeline, and you can convert. For example, their ability to roll up logs into metrics, for example. How would you do that? If you do that through the same processor, you can do this sort of logic, or just as we do in other cases of rolling up traces, span data into metrics as well. So when you have it all in one collector, it makes very much easier to do these sorts of cross-signal correlation and also cross-signal roll-ups and aggregations like that. So I hope I answered. And there are also places where you can actually ingest like FluentBit into the collector or things like that. So you can actually combine, like you have the edge agent still being FluentBit, and you can have a backend, let's say in the ingress point, having an OTel collector that you can collect to. And with the one last note, with the op-amp that I mentioned, the protocol that controls, going on to the operability, you can control with op-amp a mixed environment with mixed agents. So both OTel collectors and FluentBit and FluentD would potentially be governed with a single op-amp protocol.
Hi, my background is as a SRE, and I have a pet peeve where most of this data is usually just accessed through chronologically, right? And we have retention
through the, sorry, I didn't hear, through?
Chronologically?
Okay.
Yeah, so the data, usually you're scanning back and forth over time, but it's hard to find something that's specific to a particular incident or particular time when you did a particular benchmark, and trying to look at the data just from that particular event. And the other problem is the data will expire over time because you can only hold up to maybe 90 days or something. So it seems like there's an opportunity to have a more event-based approach for like archival of like, hey, this incident, I want to retain it for the next 5 years even. Or this benchmark I need to retain for a certain period. But I haven't seen any of the kind of telemetry, observability people thinking about looking at, basically creating a library of observability data that way.
It's a long question, so I'll try and answer it shortly because I know we're running out of time. first of all, I have a talk tomorrow on the observability track about observability as a data analytics problem. I think you should definitely check it out because there I talk about the observability best practices and patterns. It goes well beyond OpenTelemetry. First of all, because OpenTelemetry is mission, as I mentioned, is only on the generating the telemetry and collecting it, but then it sends it off. The storage and analytics part is outside the scope of OTel, and much of what you ask for is about actually how to store, how to maybe compress and roll-ups, and then how to analyze it. So it's beyond the scope, much of that. Obviously, if you do the roll-ups upon collector and then you don't even send it to the backend, then you lost the data. You lost the granularity. I can tell you, for example, on the discussions on the specification of continuous profiling, for example, there's been a lot of discussion going on about whether we should do aggregated information or event-based. If the decision now is pprof, and pprof is aggregated, so it's trends over time, but then you lose the individual events. But it is a question that came up, and potentially it will evolve into event-based as well. So there's a lot of discussion all the time with the community, especially around specifications, whether you want event-based or aggregated, especially for metrics and the profiles that are things that lend themselves for this sort of data. In terms of, you mentioned more of the storage and analytics, I will leave it to my talk tomorrow because it's a bit beyond this scope. But I hope that I answered the question. Who else? Do we have time for one last question?
Maybe we should allow one of our sponsors to be on the podium.
We have another sponsor. So thank you very much for listening, and I'm here if you have more questions. Thank you very much.
Thank you, Dotan.